how to solve inequalities. First, let's complete the table that is in your notes. Starting with the statement at the top of the table, 8 is greater than 4. This is a true statement, and therefore we will be doing different operations on that original statement to see what keeps it true and what might change it so that it is no longer true. So starting with 8 plus 10 and 4 plus 10, that gives us 18 and 14. And as you can see, the left side is still greater than the right side. Subtracting 10 from both, we get 8 minus 10 is negative 2, and 4 minus 10 is negative 6, and this still leaves us with the left side being greater than the right side. Now we're going to add a negative number. 8 plus negative 10 and 4 plus negative 10 gives us negative 2 and negative 6 again, and as we can see, negative 2 is greater than negative 6. So the left side is still bigger than the right side, and now we're going to subtract a negative. 8 minus a negative 10 becomes 8 plus 10, that's 18, and 4 minus negative 10 becomes 4 plus 10, which is 14, and the left side is still bigger than the right side. So far, as we can see, adding and subtracting positive and negative numbers, the left side is still going to be greater than the right side no matter what we add or subtract from 8 and 4. Now let's take a look at multiplication and division. 8 times 2 is 16, 4 times 2 is 8. The left side is still greater than the right side. 8 divided by 2 is 4, and 4 divided by 2 is 2, and we can see the left side is still greater than the right side. 8 times negative 2 is negative 16, while 4 times negative 2 is negative 8. This is not true that the left side is greater than the right side. For the very first time, we can see now that the right side, negative 8, is actually greater than negative 16. And then finally, if I divide by a negative number, we end up with negative 4 and negative 2, and again, the right side is bigger than the left side. The only times that this occurs where our original statement of the left side being greater than the right side is no longer true is if I multiply or divide by a negative number. My left side is no longer greater than the right side, because starting with a greater positive number, ending with a greater negative number, this is actually, as the nature of the number line, this is actually farther to the left down the number line as negative 8, which means it is actually smaller than negative 8. So if we remember on the number line, the negative side of the number line, the numbers are numbered backwards. So negative 16 is actually less than negative 8 because it's farther to the left down the number line. This is a very important thing that we need to remember when we're solving an inequality, because when we are solving an inequality, we need to flip the sign in our answer if we multiply or divide by a negative. The reason is because we're essentially flipping the relationship between the numbers on the number line. When multiplying and dividing, what was larger becomes smaller and vice versa. This does not, adding and subtracting does not change which one is larger or smaller, as we saw in our table. Even if we add a negative or subtract a negative, this side is still greater than this side. We need to flip the sign to make sure that our inequality remains true after we're doing that multiplication and division with a negative number. If we had left it facing the opposite direction, that would not be a true statement. So what we want to write down is if you multiply or divide on both sides of an inequality by a positive number, your inequality stays the same. However, if you multiply or divide on both sides of an inequality by a negative number, we must flip the inequality symbol to its opposite. So let's take a look at some examples. As we are solving these, all of our steps are the same as when we had an equal sign. The difference is that we want to keep that inequality sign and then graph our answer at the end. If our step includes a multiplication or a division by a negative number, we will have to flip the inequality, and we will take a look at when that occurs. So starting with example 1, we're going to first start by adding 12 to both sides so that that negative 12 can cancel out. Here we have 18 is less than 4x. We're going to divide both sides by a positive 4. So the number we're looking to see if it's going to flip or not is this number that we're dividing by. So the one I'm highlighting in green, if this is negative, we would need to flip the inequality sign. But it's positive, so we do not need to flip the inequality sign. So we end up with 4.5 is less than x, or if you like to see the x on the other side, x is greater than 4.5. So to draw our number line, this is going to give us an open circle with our arrow to the right. You could also number your number line with halves if you want, or you could just put the circle halfway between 4 and 5. So that is example 1. We solve like normal. We just keep, instead of an equal sign, we keep our inequality sign. Since I divided both sides by a positive 4, I don't have to flip anything to keep a statement true, and we solve it and then graph it at the end. Just to make sure we're correct, if you pick a number that's greater than 4.5, let's say like 5, and then you plug it into your original problem, you should get a number that's greater than 6. So negative 12 plus 4 times 5 is 20. That's 8, and 8 is greater than 6, so that means our solutions are correct because numbers bigger than x will work. In example 2, we will subtract 6 from both sides, as we normally would do, solving an equation. Now we have negative 1/3 k is greater than negative 15. Now, when we solve this, we will be multiplying both sides by a negative 3/1. If you like to put the ones here, you can. This is the number we need to focus on. If this number is negative, then we are going to flip our inequality. It does not matter what our starting value is here, negative 15 or positive 15. If this number is negative, we will need to flip our inequality. So what happens is this all cancels out. K is left. Negative 15 times negative 3 is a positive 45, but we need to reverse this inequality from a greater than to a less than to ensure that our values are true. When you graph it, we graph it as usual by putting an open circle above the 45, and our arrow is going to go to the left. To double check to make sure that that is correct, picking a value for k that's less than 45. Now, because I have to multiply it by a negative 1/3, I'm going to pick a multiple of 3. So I'm going to pick 15. If I plug in 15, negative 3 times 15 plus 6 should give us an answer that's greater than negative 9. So negative 1/3 times 15 is negative 5. Plus 6 is 1, and that is greater than negative 9. So that is telling us that all values that are less than 45 would work. If you forget to flip this symbol, and you said k should be everything greater than 45, if you pick a value for k that's greater than 45, it will not give you a true statement. For example, I would pick, let's say, 75, because that's divisible by 3. So if I do negative 1/3 times 75 plus 6, 1/3 of 75 is 25, but it's negative, so negative 1/3 times 75 is negative 25, plus 6 is negative 19, and that is not greater than negative 9, which is what it's supposed to be. So you can see that if I don't flip the inequality sign, those values are not true if I plug them into the original inequality. So again, because I ended up multiplying on both sides by a negative 3, I had to flip the inequality sign. Let's look at a few more examples. For example 3, I'm going to start by distributing the 2 to the negative 3h, that's negative 6h, minus 2 times 6, which is 12, less than or equal to 18. I'm going to add 12 to both sides, leaving me with negative 6h is less than or equal to 30. And then here, to get h by itself, I'm going to be dividing both sides by a -6. So again, if this number that I'm writing in green, if that is a negative number, then that means I'm going to need to flip my inequality because I'm dividing both sides by a negative. So it becomes h is greater than or equal to -5. Drawing my number line. Make sure when you're doing a negative number line, you're putting the numbers in the correct order. This is a closed circle, arrow to the right. One little kind of hint is you can kind of get a head start. If you look at the original problem at the coefficient of the variable, the number in front of the variable, if that number is negative, then you are going to need to flip this sign, because that's the number that you multiply or divide by at the end. Now, example 4, this is a tricky one because we have a -5 here, but we have a +2 here. So this one kind of depends on how you solve it. I would solve by adding 5g to both sides so that I end up with a positive on the right side. So -13 is greater than 7g plus 8. Subtract 8 on both sides, you get -21 is greater than 7g. Divide both sides by, oops, I'm going to write this in green again as I have been, by a +7. So again, if that number I'm dividing by is negative, we're flipping, but it's not. It's a +7 when I'm dividing by. Okay, not what I'm starting with, what I'm dividing it by. So -21 divided by +7 is a -3, is greater than g. And if for graphing purposes, it helps you to put the g on the left, that would be g is less than -3. I'm running out of space, but as a quick graph, that's going to be an open circle with our arrow to the left. Okay, be careful if you're not rewriting it to put the g on the left. Make sure you're reading it correctly, drawing the arrow to the left. So this is saying -3 is bigger than g, all of the other values that you could plug in. So -3 should be the biggest. All the other values should be less than that. Those are represented by the letter g because you could plug in an infinite number of numbers there. That's why we draw the arrow going on forever, because every number to the left is less than -3. Okay, just before we solve some more problems, just to get a little bit more practice with deciding whether or not I need to flip, let's take a look at some of these problems, and I want you to think about, should I need to flip it or not? Again, remembering that the hint is to look at the coefficient, the number in front of the variable. If that is negative, you will need to flip. Pause the video if you need more time to decide. You will need to flip this one because we have a -1/2 times x. So after we subtract the 7, we would end up having to multiply both sides by a -2/1. So we will need to flip this one. We will also need to flip this equation because even though I'm distributing, this ends up as a -9t, and then the coefficient is a negative. And then lastly, this one down here, because we have a negative in front of our x, and that means we will have to multiply by a negative or divide at the end. Here's a few more for you to try on your whiteboard for some extra practice. Pause the video, and when you're ready for the answers, unpause.